Hi everyone, it's Raden Vijay again. Today I'm going to tell you about binary search, it's about how to use it, when to use it, and when not to use it. Binary search is an algorithm to search for a value inside a list. For example, you have a list of thousands value, and instead of searching for a value in each one of the list, we will divide the list into two. The one that contains the smaller portion of the value, and the larger half contains the larger portion of the value. And then from that list, we will divide it into two again, and we will divide it into two again, and essentially turning your data from a linear list into a tree. As the data is now formatted into a tree, there are certain advantages that we can find between sequential search, or searching the element from one by one, to binary search. For example, the complexity. On binary search, the complexity is O log 2 to the n, and where n is the number of the data. Well, for the sequential is On, because you have to search for each and every element on the search. Therefore, sequential search is very easily done. You can just use a regular for loop and just iterate for every element of the loop. However, binary search is little trickier. It's natively recursion, and although it can be done in iteration, but it's maybe a little bit longer and a little bit complicated. Binary search is also a lot faster because of the complexity is so low, and it's quite tricky to implement compared to sequential search. Sequential search is pretty straightforward. I'm using a for each loop to iterate each and every element on an array and compare to the needle. When the value is found, then the loop breaks and return the value with it. While the binary search is a little bit more complicated, I have min key is the most left of the data, and the max key is the rightmost of the data, and tab is used to measure how the recursion goes. When it first runs, it will count the haystacks. The recursion continues only when max key is larger than min key. I will count the middle of the array, and it's safe, integer safe, and I will use starship to compare the needle to the data in the middle. When the data in the needle is smaller, then it will execute binary search from min key to mid key, and when it's larger, it will execute the recursion from mid key to max key. Otherwise, data is found when it's 0. Okay. Result is false to exit the recursion, so it's not going infinite loop. Randomize. This will generate two kinds of random numbers. First is sequentially random. It will add, so it's always larger than previous number, and its jump is how big its maximum jump. And this one will check for duplicate, and if duplicate is found, it will keep generating. Now I'll explain you about sorted. It's just calling randomize with 5 million of data with maximum of 1 billion. Okay, and it has to be sequential, and this will find the target is random number from the array, and this one recording the search time, and this used to record the search time. Okay, now let's go to execution. Executing sorted PHP. Okay, it's take a while to generate 5 million of data. Okay, sequential search time 0.62 seconds, and what the binary is, okay, a few microseconds. Good, binary is a lot faster. Okay, let's now reduce it to 1 million. At 1 million, execution time is 0.88 seconds, and okay, also a few microseconds. Almost no change for the binary search because the complexity is only like 2 volts. It changed, so it doesn't change. But you can see the timing between the sequential search and say for 5 million and 1 million is almost 5 volts. Yeah. Now let's see with unsorted data. I'll find 1 million first. This time Okay. As you can see, for sequential search is just 0.3 seconds, 0.03, sorry, and binary search is 0.00013 seconds. However, you can see the sorting here, sorting time, it's almost 0.2 seconds, hence the total time is about 0.2 seconds. That's why binary search is slower in this case. And now we will see with 5 millions of data. Okay, 5 millions, that's a lot. It will also take a while to generate the data, and done. Okay, see, we can see that sorting time is 1.12 seconds. It's a lot longer than the time required to search in sequential time, and however the binary search is very fast. This code is a bit useless, I think, using binary search on this kind of data, because it will actually be slower than the sequential search. However, you can see here the sequential search for both random and organized data is both the same. However, it's interesting to see that here the target found for sequential search, okay, is different to the binary search. Do you know why? It's simple, because the binary search destroys the relationship between index and the value. The result is binary search is actually a lot faster compared to sequential search. However, when you have to sort the data and then binary search it, it's actually slower than sequential search. And the worst thing is binary search cannot find more than one result. For example, if you want to have like several index on the array that contains the very same value, binary search will not find all of the value. It will just find one and return it. While sequential search can be easily programmed to find all the values. We should not use binary search on unordered data. The index must be a sequential integer, and the data must be integer or float. Perhaps strings can work if we have some string comparison function that will work it like comparing integers, and the data must be sorted. However, sorting it will destroy the index, the associativity of data and key, and in the end the binary search will return wrong index. However, if we try to keep the correct index with the sorted data, which is possible today, binary search will not work, because binary search works by comparing index. So if you have like index 1, 2, 5, 6 and 10, okay, and the value is between 2 and 5, for example like 3, there's no index here, okay, binary search cannot access this. It will just, okay, 5 good, 2, this index never exists. So yeah, it doesn't work that way. So binary search will not work. So I hope my video does help you in learning computer science, and binary search is actually very basic recursion. And if you have a question, you can drop me a comment below, and I may try my best to answer your question. And don't forget to subscribe and like, and have a good day, and take a good care of it, because the virus is still around and getting more fierce every day. And have a good day. Now let's see the source code in a little deeper. You can see that this binary search function is needle haystack, and we already read before. It's a little complex, and you can see the starship operator. Why I use starship? Because I've never done any programming using starship, so I just want to find a way to use starship, and I've got it here. And this thing is doing recursion. Actually it's pretty slow, but I deliberately make it slow because it will show the difference, it will show the exaggeration of the difference between sequential and recursion. And this function is not bug free. I think it's got some bugs when you cannot find the number. I think this thing will goes to infinite loop, but I haven't tried this before. But yeah, maybe you can help me try it, and maybe you can fix it, because I think it's not hard to fix, although it's tricky to write.